The most basic unit available in R to store data are vectors. Complex data sets can usually be broken down into components that are vectors. For example, in a data frame such as the murders data frame, each column is a vector. In this video, we're going to learn more about this important class. Let's start by learning how to create vectors. One way we can do that is by using the function C, which stands for concatenate. So in this very simple example, I am defining a object codes with three country codes, 380, 124, and 818. We're going to use this example going forward. We can also create character vectors. For example, we can create a character vector with the names of the three countries associated with those three codes. We use the quotes to denote that the entries are characters rather than variables. If you don't use the quotes, R looks for variables with those names, and in this case, it will return an error because you haven't defined objects named Italy, Canada, or Egypt. Sometimes it's useful to name the entries of a vector. For example, when defining a vector of country codes, as we did, we can use the names to connect the two. So here we would type codes, then use concatenate, but this time, instead of just writing out the three numbers, we would assign a name to each one. And as you can see, when we look at the object codes, we can see that the three numbers are associated with three countries. The object codes continues to be a numeric vector though. If we type class codes, we can see that it's numeric. Now, if we use strings without quotes, it looks a little confusing to some, but you should know that you can use strings here. You can do the same exact expression, but this time you use quotes to define the names, like this. There's no difference between this call and the previous one. This is one of the many ways in which R is quirky compared to other languages. Note that we can also use the names functions to assign names to the entries of a vector. Here's the code that we use that does exactly the same thing as the previous two chunks of code, but using the names function. All right, another useful function for creating vectors, and we use this often, is a function that generates sequences. The function is seq, stands for sequence. So if I type seq, then from 1, 10, it writes out the numbers from 1 to 10, the consecutive integers from 1 to 10. In this function, the first argument defines the start, and the second defines the end. The default is to go in increments of 1, but a third argument, which defaults to 1, lets us tell seq how much to jump by. So for example, if I type seq 1, 10, 2, it would write out the odds numbers from 1 to 9. Note that if we want consecutive integers, we can use the following shorthand. We can type 1:10 and we get the integers from 1 to 10. Now let's go over subsetting, an important topic. It lets us access specific parts of a vector. We use square brackets to access elements of a vector. So for example, we can access the second element of codes by simply typing codes square bracket to close square bracket. And you can see it shows us the country code for Canada. You can get more than one entry by using a multi-entry vector as an index. So we can type codes and then create the vector 1, 3, and now we get the first and third element. The sequences defined above are particularly useful if we want to access, say, the first two elements. So we can type codes and then 1 through 2, we get the first two elements of our vector. If the elements have names, we can also access the entries using these names. For example, if we type codes, open brackets, and then Canada in quotes, it'll access the entry that has the name Canada. We can also have vector of names that are longer than 1. So we can also call codes, open brackets, and then have a vector of string names, and it'll return the two elements associated with those two names.